Hi, in this video, I'm going to discuss last 10 of SMC 8, second 10 of SMC 11, and first 10 of SMC 13. Okay, let's go to the questions. Let me share. Okay, so let's start with the first question. A shop sells toffees, and for every 3 toffee wrappers, the shop gives 1 toffee free. If a toffee is rupees 25, what is the maximum number of toffees you can get for rupees 225? Now, 25 goes 9 times into 225. So, you get 9 toffees and also 9 wrappers, right? And then we can actually swap 9 wrappers into 3 toffees. So, we get 12 toffees and then 3 new wrappers, right? And then we can swap these 3 new wrappers into 1 toffee. So, we get 13 toffees and 1 wrapper, right? So we can get 13 toffees, right? Okay. What is the units digit of 7 to the 2024? So, so this is going to be a huge number if we really calculate. I don't think that we can calculate it. So let's see how the units digit behaves, right? So the first power 7, it's 7, right? The second power, 7 to the 2, is 49. So this digit is 9. And 7 to the 3 is, so we need to multiply this by 7. So we get 7 times 9 is 63. 6 there. 7 times 4 is 28. Plus 6 is 343. And 7 to the 4. So now we can see that the last digit, the next digit is 1, right? And 7 to the 5, units digit is 7, right? So we can see that the units digit, right? The 7, 9, 3, 1, right? So, and then it repeats. So this 7, 9, 3, 1, it repeats. So how many blocks are there in 2024? So 2024 is divided by 4, and we get, when you divide by 4, 506. And then at the end, we have 1, right? So the next digit is 1, right? Okay. 43. The following wavy line is made of semicircles, which are half circles, and the length of AB is 10 centimeters, right? So what is the length of the wavy line in centimeters, right? So we know the radius of a half a circle, which is 5 times the radius, right? So then the first half circle has length pi r1, right? And then let's say the second half circle has radius r2. So this is, it has length pi r2, the circumference, not, I mean, the length of this half circle. And then let's say that this has radius r3. So it is, length is pi r3. And then let's say this one has radius r4. It is pi r4. And then this one has radius r5. So this is pi r5. So what is the total length? The total length is, so I'm going to pull out pi. Pi times r1 plus r2 plus r3 plus r4 plus r5. Now, how do you find this, some of the radii? of these five half circles? Well, you can see that here we have 2R1, right? And here we have 2R2, right? So their sum is 10 centimeters, right? That means this is 5 centimeters half of the length of AB. So the length of this wavy line is 5 pi centimeters, right? So that's the answer, right? Okay, let's go to the next question, 44. In the following figure, circles connected with a line segment have to be colored in different colors. If the circles are colored with the minimum number of colors possible, then which three circles are colored in the same color? Right. So now you can see at once the circles labeled 1, 2, 5 have to be colored in three different colors, right? Because if you give this one red, then 2 has to be colored in a different color blue, and 5 has to be different from both red and blue, let's say yellow, right? What about number 6? Now for 6 we can give red color, right? And for 7 we can give yellow, and for 3 we can give red, right? And of 4, of course, it can be either yellow or blue. So you can see that 1, 6, and 3 are in the same color. And now, so this is what you do in the competition, right? Because we found the coloring, and in that coloring, 1, 3, 6 are in the same color. But when you do this at home, then you have to think, okay, do I, so in any coloring, do these circles 1, 6, 3 in the same color? So can you see that they get the same color? Okay, so let's go to the next question. Dulani, Netmi, Isuri, and Pavitra make the following statements about 4 cars, which are either red or blue, with at least one red car and at least one blue car, right? So that means answer has to be either one red and 3 blue, or 2 reds and 2 blues, or 3 red and 1 blue, right? Now, Dulani says the triangle number of them is red. Now, what are triangle numbers? So these are numbers which actually can be, if we denote dots, we take the same number of dots as a number, we can arrange them in in a triangle, for example. One is obviously a triangle, and 3. So here, we take 3 dots, and here we have a triangle. So Duran says that 1 or 3 are red, right? And then he still says that the prime number of them is red. So that means 2 or 3 are red. And let me say that an even number of them is blue. So either 2 or 4, but it can't be 4. So then 2 are blue. That means she says that 2 are red, right? And then Paitra says that the square number of them is blue. So 1 of 4, but it can't be 4. So 1 is blue. A square number. That means if you take dots, a same number of dots as a number, then they can be arranged in a square. For example, 4 is a square number, right? All right. But it can't be 4 blue, so it means 1 red, 1 blue, that means 3 red. Now, if only 2 people told the truth, how many red cards are there? Now, if it is 1, only Dulani said, if it is 1 red, only Dulani said the truth. And if it is 3 of them said the truth. But if it is 2 only, we have 2 people exactly two people saying the truth, right? So that means 2 has to be the answer, right? Okay, so let's go to the next question. If in the following figure, the areas enclosed by the egg-shaped circles represent different number types, then which of the following gives the number types that can be accurately represented by the figure? So we have one big red egg-shaped circle, and inside we have blue and green. They seem to be intersecting, and then inside blue we have a gray one, and it does not intersect the blue one. Sorry, the green one, right? So if let's look at the response A. Even numbers or numbers, they are not intersecting. So it could be gray and green, but multiples of 4 are inside even, right? But then blue and green are intersecting, it can't be. So the numbers have to be the bigger one, which is red, right? So how about this one? So this can't be, right? And prime numbers, even numbers, multiples of 2. So primes and, well, we know that 2 is a prime number, only prime number, which is even. So that means all these 3 are intersecting, right? So it can't be. What about this one? So prime numbers, even numbers, intersecting, but multiples of 4. So multiples of 4 are actually no intersection with the prime numbers, right? And then even numbers contains multiples of 4. So this is actually the answer, right? So this fits. So in prime numbers, we can have so this could be prime, right? And blue, even, and gray, multiples of 4, right? Okay, so this is the answer, but they need to check in that D and E are not correct, all right? Okay, so we move on to the next question. There are 5 cards. On each card, there is a letter on one side and a digit on the other side. Right. So cards are laid out on a table as follows. Right. Some of the cards may be all flipped and rearranged as follows. How many sides have an odd digit? Right. So when you look at this second row, right, so you can see that the digits are 4, 1, and 2. And here we can see that uh, uh, we have digits 4, 7, and 7, right? And when you look at this, right, you can see that, so the 7 actually appears twice, right? And then 4, 1, 2, so it has to be 4, 1, 2, 7, 7, right? So how many sides have a digit? So you can see that there are 3 odd digits, 1, 7, 7, right? So 1, 7, 7. Hope you got it. If you didn't get it, well, you can stop the video, work it out, and you can rewatch. All right. Okay, let's go to the next question. ABCD rectangle is made of 8 congruent rectangles. What is the ratio AB to BC? Right. So it is better that we label the sides of this rectangle, right? The smaller one, right? Let's say this has X and this has Y, right? The shorter side is Y, the longer side is X, and AB to BC. So this is actually what? AB is X plus Y, right? See, this is also Y, right? To BC, which is 3 times X, right? X, X, so 3 times X. So we need to find out X plus Y over 3X, right? Right. So now X, Y, 3X can be expressed Y in terms of X. So here, we have here Y, 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 Y. So 5Y is equal to 3X. See here, uh, BC, 3X, right? So 3X is 5Y, and we can actually multiply both the top and the bottom by, if you like, 3, right? So we have 3X. Then you will wonder why I multiply this by 3, and this will be clear in a moment, right? And we replace 3X by 5Y. So 5Y plus 3Y or 9X, which is actually 15Y, right? 15Y. 3 times 5Y, right? 15Y. Wait a minute. What am I writing? So this should be in the bottom, right? 15Y. So, so don't get confused with this. This is actually the relationship between X and Y, right? Now we can simplify. So 8Y over 15Y, right? And this is 8 over 15. And this ratio is what? 8 to the 15, right? It is 15. Okay. All right. So we go to the next question. Each of the digits 0, 1, 2, 3, 4, 6, and 7 can be placed in the boxes to form a correct addition with a 3-digit sum. What is the digit sum? Which is the sum of the digits of the resulting sum. Right. The question is clear, right? Now, how many digits are here? So we have actually how many? 0, 1, 2, 3, 4, 6. We have 7 digits and 7 boxes, right? So that means each box get different boxes get different digits, right? Different boxes get different digits. Now, I'm going to focus on this box first, right? And I can see that it has to be 1. How? Because here, right, the maximum would be, right, I'm going to put 6 and 7 in the tens places. So 7, 6, right? Here 7, here 6, right? And that means this is going to be 130. So definitely less than 200, right? So that means this has to be 1, right? It has to be 1. It can't be 2 or more, right? It has to be 1, right? And it can't be 0 because it is a 3-digit sum, 3-digit sum, a 3-digit number, right? Now that we found, right? Okay. Now then I'm going to focus at the digit 0. Digit 0 can't be in any one of these two boxes, right? Because when you put that, then whatever digit you put in the other box, right, you get the same number here. Let's say we put 0, 2. You get 2 here. It can't be because different boxes, different digits. So that means 0 can't be in these two boxes, right? And can 0 be in these two boxes? No, because if we to put a 0 here, right, then this is actually a 1-digit number, and plus this is a 2-digit number, and their sum has to be less than 100 because we don't have 9 here, right? You got it? We don't have 9 here. So we can't have 0 here too, right? So that means either 0 is here or 0 is here. Okay? Got it? All right. I'm going to erase, right? So where can 0 be? So either it is here or here. If it is here, it has to be 4, 6 here, right? And then what about these two boxes, right? If you're going to get a 1 here, right? So we have a carry of 1, right? So this has to be the sum of these two boxes, 9 or more. So 9 can be 0 and 2. So if it is 2 and 7, then what do we get? We get 0 here, 0 here, can't be. Because this carry over, right? 1 plus 7 plus 2 can't be. So how about for 6? We put 7 and 3. So 0 here, and then carry over 1, 11, right? Can't be, right? So it can't be 4 or 6. Can it be 7 or 3? 7 or 3? So this has to be, these two boxes have to be 9 or more. Can we have 9? Yes, 6 and 3. In that case, 0 here, 0 here, no. Right, can it be 7, 3, 6, 4? So 0, 1, 1 can't be. So that means, right, we have found where 0 is, right? It is definitely, right, here, right? All right, what about the other numbers, right? Now, I'm not going to completely solve this, right? I'm going to leave something for you. What is that? Leave something for you, right? This has we call a unique solution, right? Unique solution. I will not show you the solution. Well, I will show you the solution, right? But they need to find out how we can show that it is the only solution, right? Okay, it's going to be 7, 3, 2, 4, 6, right? That's the solution. Unique solution, right? Now this, so here you can actually use logic and guess and check, right, to find the answer very quickly. All right. So I showed you how you can actually logically find out that 1 is here, right, and 0 is here, right. And also I showed you that um, yes, right, and then show that this is the unique solution, right. So this actually, you can see that all the 7 digits are there, and the addition is correct, right. Addition is correct. So what's the digit sum? It is 7. That's the correct answer, right? All right. So we go to the last question, right? A, B, C, D, E, F is a regular hexagon. What's the ratio of the area of A, B, C, D, E, F hexagon to the area of the A, B, C, D, E, F star? Right. You can see the star shaded in gray, right? So, so if you see carefully, right, you can see that there are these rhombuses, right? Rhombuses, right? And if you see carefully, you can see that these rhombuses, right? There are 6 of them, right? So I'll actually outline 3 in color, right? And then here is the so 1, 2, 3, and here's the 4th one, right? And this is the 5th one, and this is the 6th one. You can see 6 rhombuses, and they are also congruent, right? Congruent. Shape, shape, and size are the same, congruent, right? Right. So the star is made of 6 congruent rhombuses, right? Now, you can find out that that this angle, right? So these are, now if you look at these triangles, right? You can see triangles there. Each triangle is equilateral, so this is actually 60, right? And this is a regular hexagon. This angle is now we know that in a polygon, right? Uh, Actually, convex polygon, right? Interior angles sum up to n minus 2 times 180, and is the number of sides, right? So this actually, and it's 6, we have 6 sides, so 4 times 180, right? And since this is a regular hexagon, right, then you divide by 6, right? And you can see that so this is actually 120, right? So the interior angle is 120, so this is 120, right? All right. So that means this is 30, because and this is 60, right? So then this is also 30, this is 120. So you should be able to see that, right? This part, right, is actually half of this rhombus. So I said that this star is actually, it is made of rhombuses, right? And you can see that this is actually half of this rhombus, right? So how many halves are there? We have 6 halves, right? See, 1, 2, 3, 4, 5, 6 halves, right? That means 3 rhombuses, right? So the hexagon is made of how many rhombuses? So it is 6 plus 3 rhombuses, right? And the ratio 6 plus 3 to 6. So 9 to 6, and that means 3 to 2. So the ratio is 3 to 2, right? Yeah, so I did this quickly, right? So when you do this at home, right, you need to go over the details, okay? Right. So that is the end of the last 10 of SMC 8, and the second 10 of SMC 11, and the first 10 of SMC 13. Okay, so that's it. So I'll see you in some other video. All right. Okay. See you then.